There we go, fixed. All right, and then this one's the same, right? I forgot to put that there. All right, so this part creates the alternating. This creates the numbers. So that 1 over n plus 1 right there, and then on this one, the 1 over n plus 1, that 1 over n plus 1 is our b sub n. That's the b sub n in both of those. Do you understand? I'm just separating the negative alternating from the actual part that creates the numbers. All right, so what is the alternating series test? This is one of the easiest tests to actually implement. Like out of the tests that we've learned, this is one of the easiest ones to actually execute. So it says, all right, look, let's say you've got an alternating series, right? You've got some alternating series. There it is. It's either going to start negative or start positive. In either case, you're going to have a b sub n, right? You're going to have b sub n in there. Here's what you need to do. This is a test to see if it converges. First thing, you want to show that the sequence is decreasing. So you want to show that the nth term of the sequence is always bigger than the next one. And then the other thing you need to show is that the limit of that new sequence goes to 0. That's it, those two things. If you can show those two things, the series converges. This is also on your sheet, right? Your table. So let's do an example. Look at that series right there. Ooh, I'm not giving you the formula, right? We have to come up with a formula. So 1/2 minus 1/3 plus 1/4 minus 1/5 plus 1/6. I think you get the idea. Minus 1/7 plus ... So does this converge or diverge? Ready? First thing I notice is that's alternating, right? It's alternating. So what I'm going to do is I'm going to come up with a formula for it. So it's sum n equals 1 to infinity. This is the exact formula, or the exact series I gave you just a second ago, right? It starts positive, so I'm going to use -1 to the n minus 1. I could use n plus 1, right? I could use n plus 3. That part doesn't matter. That's the part that makes it alternate. Okay, so I've got that, right? Everyone agree that's going to start us positive? And then what are the numbers? If I ignore all the positives and negatives and stuff, it's 1 over n plus 1, right? That right there. There it is. All right, that is our series. This is our b sub n. All right, now, I'm going to use the alternating series test. Why? Because it's an alternating series, right? Could I use the comparison test? No, remember the first condition of the comparison test is that these had to be, the comparison test, all the terms have to be positive. So you cannot do a comparison test here. Okay, so I'm going to do the alternating series test. I'll just call it AST from here on out. Alternating series test. Okay, what do I want to show? I want to show two things. First, I want to show that b sub n is greater than or equal to b sub n plus 1. On your sheet, is it greater or greater than equal? Certain books do it certain ways, I forget. Greater or equal to, okay. I want to show that. And then 2, I want to show the limit as n goes to infinity of b sub n, that must equal 0. Those two things I have to show. If both of these things are true, then I can tell you that that series, what? Converges. Okay, looking at this, which of those two seem easier to you right now? 1 or 2? 1, showing decreasing seems easier? Yeah. Or taking the limit of the sequence part, the b sub n? What does this mean? Take the limit of this, right? Let n go to infinity. What do you get? 0. Right? Like this is pretty straightforward right now, isn't it? Okay, but I'm just trying to get you to see ahead. I'm going to go in order. First thing, I'm asking this question, is b sub n greater than or equal to b sub n plus 1? Right? That's what I'm asking myself. Is this true? Well, what is b sub n? 1 over n plus 1. Is that bigger than or equal to, what's b sub n plus 1? That's what you get when you plug n plus 1 in here for n. So what would happen if I plug n plus 1 in here? It would be 1 over n plus 2. Is that true? Is this true? It's true. Because that's true, right? And if I subtract n on both sides, 2 is greater than or equal to 1, and that is true. Do y'all understand where I got n plus 2? No?
I don't.
No? Okay, so b sub n is this, right? B sub n is this.
Yeah.
So if I asked you, what's b sub 4, what would you do?
1 over 4 plus 1.
Okay, 1 over 4 plus 1. If I say, what's b sub t, what would you do?
1 over t plus 1.
Okay, so if I ask you, what's b sub n, what's b sub n?
1 over n plus 1.
What's b sub n plus 1?
1 over n plus 2.
There you go. So you just answered. You just answered your own question. Right? Right? Are you good?
No.
Yeah, you are. All you did was plug n plus 1 right here. Right there, you replaced it with n plus 1. It became n plus 1 plus 1, which is n plus 2.
Right.
Yeah. Okay, so that's true, right? First thing? Yes? Second thing I have to show. I want to show that the limit as n goes to infinity of b sub n, so that's 1 over n plus 1. I need this to be 0. And it is. Now look, please do not confuse this with the pregnancy test. The pregnancy test, when we do that, we're looking at the entire thing, right? And we do the pregnancy test. And if we get 0, what does it tell us? Nothing. With the alternating series test, when you isolate the b sub n, then if you take that limit and get 0, it actually does tell us something. But we need this to hold as well. If these two things hold together, then we can say it converges. So both things held, therefore, the original series is convergent. Converges. That was weird. That felt like me asking you, what 2 plus 2 was, and you said 4, and then I say, you get it now? And you're like, no. Well, you just did it. What's that? You're thinking about tomorrow? Yeah. What's tomorrow?
Thursday?
Yeah. I know, this is, fall is the worst semester, especially towards the end in a class like this. I have the same problem in my Cal 3. Everyone's trying to check out. It's like, this is going to be the difference between passing and failing the class. This last test is hard. It's hard. You got to find a way to get it in there. Yes?
You said the only two we can find that converges to is geometric. What was the other one?
The only two series that you can actually find the sum of with any sort of relative ease are geometric and telescopic, which we aren't even doing telescopic, right? We skipped it. I skipped it last class. Yeah, so we're not even doing those. Okay. So we're at a point here where, let's do this one. I wanted to skip it, but we're going to do it. Well, I shouldn't say difference between passing and failing. I mean, it could literally, what happens in the next 2 weeks, we only have 2 more weeks of school. That's it. That's it. 2 more weeks, we have 4 lectures. That's it. 4 more of these meetings, and then we have a final. So what happens in the next 2 weeks here can be the difference between an A and a C. You can go from an A to a C in one test. So or from an A to a D, you know. I don't want that to happen, so just find it in you, okay? Does this converge or diverge? All right, so I look at it, I'm like, well, it's alternating, right? It's alternating. And it's already been written down, so I already know what my B sub n is, right? So if I'm going to use the alternating series test. Do I seem like I've checked out? Do I seem any different?
No, not at all.
Good, then that's the way you need to be too, all right? Because I've been doing this for over 20 years, and I realized Chapter 8 is important. I'm still trying to be eager and enthusiastic about the information, right? So I need you to come with the day one mentality, right? Bring it. All right, first thing. I want to show that this is true. Decreasing. You're going to do this. B sub n greater or equal to B sub n plus 1. This is a question, right? I don't know if this is true. I want to see if it's true. All right, you ready? What's B sub n? Yes, that's right here, right? That's it right there. That's B sub n. Okay? You get to tell me exactly what this is. This right here. NQ plus 1. Okay, so
it's going to be n squared over NQ plus 1,
n squared.
and then plus 1.
Oh, okay. Oh, I see what you're doing. So what you're doing is you're taking this and you're just adding 1 to it.
Yeah.
No, you're replacing the n's with n plus 1s. You're replacing the n's with it. You're plugging n plus 1 into this.
Oh, okay.
Okay?
It's n plus 1 squared.
There you go. It's n plus 1 squared over n plus 1 cubed plus 1. There we go. We good now?
So.
What's wrong?
Supposed to be B sub n plus 1? Yes.
Yeah, it's b sub n plus 1.
That's what I was thinking.
Yeah, does my notation not look right? You were thinking like that?
Yeah.
Okay.
Yeah.
Really? Is it that hard to see? Okay.
Honestly,
It's not.
Okay.
Notation.
No, these are not the same thing. This is not the same thing as this. This right here means take b sub n, which is what you were saying, n squared over n cubed plus 1, and then just add 1 outside. That's different than b sub n plus 1, where the n plus 1 is down in the subscript. That means you're plugging n plus 1 in for the n. Oh, good. I'm glad we resolved that. Because that would confuse the hell out of me, too, if I wasn't making that distinction. It's the notation. We never use parentheses. It's never written that way, ever. It's always subscript. There's no parentheses around it. So it's kind of like the difference between this. If you say f of x versus f of x plus 1, right? This means you plug x into the function. This means you plug x plus 1 into the function. But that does not mean f of x plus 1. That means you plug x into the function, then you add 1, right? So those are different notations. So I can see where y'all are seeing that, but now you see these two written out side by side like this, and you can tell the difference? Okay. Wow, I'm glad we resolved it. That would have been, you would have continued to struggle with. All right, now I need to know if this is true or not. Is this true? Maybe, right? Okay. So,
boil it out.
we could do our thing and we can start messing with this. And I'm not saying that it's not impossible. It's the algebra would work out here, but I want to show you something that you can utilize as well, and that is showing that a sequence decreases. Right? That's what this means, decreasing. The nth one, the nth dot in your sequence is bigger than or equal to the next one. There. Parentheses. No. We don't. The nth one is right here, n plus 1. that the next one is below it, okay? That's decreasing, right? Instead of doing this algebra, I could go back to the integral test. How do we show something decreased with integral test? Derivative. We could look at this as a function and take its derivative and show it's negative as well. It's totally up to you. What do y'all want to do? Derivative of that, show it's negative, or just algebra over there?
I want to do the derivative.
Y'all want to do derivative? 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 That algebra is not too bad, but yeah, let's do derivative. So let's talk about this derivative. The derivative of that, I'm going to take the derivative of this, and what am I hoping this is? Negative, right? Is the derivative of that negative? That would mean it's a decreasing function, which means the sequence decreases. Right? Okay, so derivative of this, I use quotient rule, right? Derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. Is that less than 0? Question. Well, we still have to do a little bit of algebra up top. Let's see. Here, we get 2x to the 4th plus 2x minus 3x to the 4th over what? Some positive number, right? Do you all agree this is positive no matter what? So if I want to know if this is less than 0, really, what do I need to happen right now for this to be true? I need the top to be negative. Is the top negative? Let's continue cleaning it up. Look, these are like terms, right? So this is really 2x minus x to the 4th over some positive number. Is that negative?
Yeah.
Yeah, I think eventually, right? Like if x is 1, right? If x is 1, it doesn't work, does it? X is 2, I don't know if, it works for 2, doesn't it? 2 and 3 and 4 and 5. Eventually, this thing dominates, right? That thing dominates. If you're not seeing it there, you could even pull a GCF out, like that. And you could say, okay, what do we know about this number? Always what? Positive. That's always positive. So the question is this positive or negative? Well, again, at 1, it's positive, right? But at 2, that's it. It starts being negative from there on out. So it doesn't initially decrease, but then boom, it starts decreasing. So is this true? Yes. Okay, that's the first of 2 things I have to show. The other thing I have to show is what? The limit is n goes to infinity of that is 0, which it is because you're going to get infinity over infinity. You're going to use L'Hopital. (2n over 3n squared). N's cancel, you get 3, what is that, 2 over 3n, right? Cancel an n, and then that goes to 0. So it goes to 0. Check. So what can you tell me about that series? It converges. The alternating series test will only tell you if you have convergence. If one of these 2 things fail, you don't know anything, okay? Yeah.
Would you have to boil those two, the square negative?
Yeah, you'd probably have to expand those out. Okay, the next part I am skipping. So just FYI, I am skipping 8.4.6 through 8.4.7. This is called the alternating series estimation theorem. I'm not saying it's not important, but if you ever need that down the road, when you see it, it's very easy to pick up. It's not some crazy thing. All it is it's a theorem that says, hey, look, if you have an alternating series, then if you can show it converges, that we can actually almost find the sum. You know how you just ask, what can we find the sum of? Geometric and telescopic are the only really achievable ones. The theorem says that if you have an alternating series, we can find the sum within any sort of tolerance you ever want. So if you want to know what the sum is within 1/1000th of the true sum, we can find it. And the theorem tells you how many how many terms you have to go out to get that accuracy. If you want to be within 1/1,000,000th of the true answer, it'll tell you, okay, go out 70 terms, add those up, and your answer's correct to the billionth. Does that make sense? But for us, I mean, you would use a computer for that. You'd write a program to do that. That would check and say, okay, it would use the theorem. The theorem tells you exactly how far to go out. You'd have the computer go out that far, stop, and then return that number. Yes?
On a test, would you want us to say where it's converging to, or if converging is okay?
So,
On a test, say
this is a great question. This is a great question, okay? So what you're asking me is, this series converges, right?
Yeah.
Okay? We just concluded that. I don't know what it converges to. I don't. And you don't. We don't. And we're not ever going to know what that converges to, right? So your answer is just going to be it converges. The only series we can actually find what it converges to is geometric. That's that one where it's a over 1 minus r, and that gives us the actual sum. Okay? Other than that, we don't know.
Because you mentioned a lot of us will use different tests.
Yes.
So say if I find that it converges, but I can't tell you what it converges to, would you take off points to say someone that does tell you what it converges to?
Nobody's going to tell me what it converges to. That's what I'm telling you. You're missing the bigger picture. When it comes to series, just in general, other than geometric and telescopic, which we skipped, other than geometric, nobody can tell you what it converges to. So if you get that it converges, you get that converges, and you say it converges to 2, I'll be like, what the hell are you talking about? You don't know it converges to 2. You don't. I mean, that would be wrong. You can't say what it converges to. You can't. Okay? You can just say that it converges. That's it. Now there are techniques to actually find these sums, but they're much more advanced. In the past, what I've done is I've had an optional lecture, if I have time, where I go over Fourier series, which are not covered in the book. And in the past, I've done that lecture. It just hasn't worked out in the last few years where I've done it, where I do an entire 2-hour lecture where we actually find the sum of a simple series. And it takes an entire Fourier transform and all this stuff to do it. And at the very end, you get the sum. And it's like all this work, and you're like, wow, just to find the sum of one series? Like, yeah, just to find the sum of one series. So it's a hard thing to do in general. So am I answering your question?
Yeah.
When you're doing these things, like right here, we got 0, right? That doesn't mean anything about anything converging to 0. That's just part of the test. It helps us conclude that we have convergence, and that's all. Yeah.
Series on YouTube?
No, I've never recorded that lecture. Yeah. I've been meaning to put something together over Fourier series and Laplace transforms, which a lot of people who take differential equations are going to need to do Laplace transforms. And if you've never seen them before, they're a little bit weird, but it's not that bad. Like, it sounds terrible, but Laplace transforms are not that bad. All right, how are we doing? Time. So I'm skipping the estimation theorem. I mostly keep it in my notes because I just want to have it there, just so that I have the complete set of notes here. All right, we're going to talk about absolute convergence. We've got 5 minutes. Yeah, absolute convergence we can do in 5 minutes because it's just a definition. So this is just a definition. So if somebody gives us a series, all right, we're given some series, arbitrary, does not have to be alternating, doesn't have to be just some generic series. Here it is, right? We consider a similar series where what we do is we take the absolute value of the sequence and then add up the answers. Right, so it's not the same, it's not the original series we were given, it's this new series that we're going to look at, where we look at the absolute value of everything. All right, and what we have is this. It's a definition. So if you're given this, let's say you're given some series, right? We know this just means adding all these things up, right, forever. Then if the sum of the absolute value, if this converges, then we say that this is absolutely, right? Yeah. Convergent. So I'm going to start with a series. I don't know if this converges or not, okay? I have no idea. I'm going to look at instead of that, I'm going to look at the sum of the absolute value. If that converges, right? If this converges, then we call this series absolutely convergent because its absolute values converged. So it's called absolutely convergent. I hate this definition because most of the time when people hear the word absolutely, they think it means like extra, just like absolute, like, you know, okay, no, it just means that the sum of the absolute values converge, all right? So let's look at this right here. Your first example and last example of the day. It's a squeaky one. Oh, I almost look like the Spurs. All right. Let's run through everything. I've given you a series, yes? Okay. First thing, end term test. Take the limit as n goes to infinity of that. What do you get? 0, right? Bounded over infinity. That goes to 0. What does that tell you? Nothing. Okay? So I don't know what happens. All right. Is it geometric? Well, do you see n in an exponent? No. Is it harmonic? Constant over linear? No. Integral test. Do I want to do an integral test on that? I can't. Why not? If I change this to a function, it's not what? It's not always positive. Depending on the value of sine, this could be negative, couldn't it? And so the integral test won't work. And also the comparison test won't work, because what does the comparison test require? That all of these are positive, and they're not. Everything is failing, right? Everything that I have in my arsenal does not work. Yeah? Okay. What was next? Comparison. Can't do comparison. Alternating series test. Does this series alternate? No. Is it sometimes positive, sometimes negative? But it's not like switch back and forth, is it? So you cannot say alternating series. I've got nothing, right? I've got nothing. I've got no tool for this. I have no tool for it, right? Here's what I can say, though. Here's what I can say. If I look at the absolute value, right, then I can do a comparison test on this. Can't I compare this to something? Because all of these are positive now. Why? Because I'm taking the absolute value, right? So I'd like to compare this to something. I only have a minute. I'm going to compare it to this. I'm going to compare it to, any guesses? 1 over n squared. Right? 1 over n squared. Why? That's p equals 2. This converges. Right? That converges. Okay. If that converges, what do I need to show? I'm going to do the inequality. I want to show that this is absolute value of sine n over n squared is less than or equal to 1 over n squared. Is that going to work? How does that absolute value work? Do I really need the absolute value on the n squared on the bottom? No, because n squared is always positive. Oh. Am I right with that? That, I need to show that that's less than that. This means this. Multiply both sides of n squared, and what do you get? Absolute value of sine n is less than or equal to 1. Is that true? Yes. The sine function is bounded, isn't it? Between -1 and 1, isn't it? So is that true? Yes. Which means this converges, right? This converges. So therefore, I'm sorry, because I am out of time. Therefore, here's what I can say. This converges, right? And what does that mean? Therefore, this sine n over n squared is absolutely convergent. Who cares? Right? Does that converge or not? Well, I don't know. It's absolutely convergent, right? Well, guess what? Look at the last theorem on your little table, on your chart. What does it say? The last one. What does it say?
Useful for series that can take both positive and negative.
But what does it say, though? If the absolute value of a series converges, then the series converges. Now, I haven't shown you that theorem. That's about to come. But basically what this does is we can say that this is absolutely convergent, which means that this original series converges. All right? You'll have to stay tuned until next week. Okay, everyone have a great Thanksgiving. Thanks for hanging out for an extra minute. Yeah, anything else? No?
I think the organic